Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an interesting problem. We have the square root of z equals a plus bi, where a and b are real numbers and I is the square root of -1, or I squared equals -1 is another way to look at it. And we're trying to find the square root of negative z bar, which is the opposite of the conjugate, the complex conjugate of z. Of course, our answer is going to be in terms of a and b, and from the given, we're going to try to find the answer. So is the answer the same as the original, like a plus bi? Is it a minus bi? Is it minus a plus bi? So there's so many possibilities, but the answer is going to be in terms of a and b, okay? So let's see how we can approach a problem like this. I'm also going to show you some numerical examples. Hopefully that'll make more sense. So if you're new to complex numbers, go ahead and check out my lecture videos where I go over basics. I also have another channel if you like algebra, number theory, and trigonometry problems, tiny bit of geometry. Check out Cyber Math, cyber with an S. You can also become a member after visiting my channel. If you want to support the channel, I really appreciate it. Great, now let's go ahead and take a look at how we can solve a problem like this. First of all, this is kind of like a non-standard problem because if they told us, okay, the square root of z is equal to 3 plus, 5i or 4i, then you could just square both sides and find z. Very easy, right? It's straightforward because that's like an exercise. But this is a problem. And there's a problem book. I think it's The Art and Craft of Problem Solving. I don't know if you've seen that book, but it's a really, really nice book full of beautiful problems. And I think in one of the introductory sections, it talks about the difference between an exercise and a problem. Anyways, so let's go ahead and take a look at how we can solve a problem like this. First of all, I'm going to look at it in the general sense. What does that mean if the square root of z is a plus bi? You can start with the following. Say, okay, suppose z is equal to x plus yi, and then the square root of x plus yi is going to be a plus bi. And the next thing you can do is obviously this expression is kind of weird because when you say the square root of a real number, if the number is non-negative, there is a unique square root. In the case of complex numbers, we have two square roots. But if you understand it to be the principal square root, then that's another story. So we kind of need to also take care of the branch, which particular branch. Anyways, I'm going to just forget about all these complexities, complications, and just focus on solving the problem, okay? With minimum rigor. Let's go ahead and square both sides. That gives us x plus yi equals a squared plus 2abi plus b squared I squared. But like I said earlier, I squared is equal to -1 because I is the square root of -1. So now you can write I squared as -1. This will be minus b squared. I'm looking at the wrong thing. So this would be -b squared. Okay? Now, what does this mean? This means that we have two complex numbers that are equal to each other. So let's go ahead and put the real parts together and the imaginary parts together. Awesome. Now, we know that if two complex numbers are equal like this, then the real parts have to be equal. So x needs to equal a squared minus b squared. Let's go ahead and write it down. And then y is the imaginary part, needs to equal 2ab. So this is what we can derive from this equation, okay? Now, basically, so if two complex numbers are equal, it's kind of like a system of equations as opposed to a single equation. Now, from here, are we able to find the conjugate of z and the opposite of that, and we're going to have to square root it? Of course, if you know that z is equal to x plus yi, right? We said that, right? Let's go ahead and find the conjugate of z, which is x minus yi. And the opposite of that would just be minus x plus yi. You just need to multiply by -1. Easy, right? So now we want to square root this number, right? That's what we want to find in terms of a and b. But how do you square root this number? So suppose you square root both sides, and in that case, you're going to get something like this. But we know that x is equal to a squared minus b squared. So negative x would be b squared minus a squared, plus yi would be 2abi, right? Now, how do you find the square root of something like this, right? Well, we do know that this expression comes from a plus bi squared. So is there a way that this can come from something similar? Yes. So here's what we can do. We can move the a squared to the end. We can put it here. And then do a little bit of hocus pocus. Are you ready for the mathematical manipulation? So here's what we do. Instead of negative a squared, we write it as a squared I squared. Because as you know, I squared is -1, so negative a squared can be replaced with a squared I squared. So now our expression, which is what we're looking for, becomes b squared plus 2abi plus ai quantity squared. What is that supposed to mean? Well, if you look at this expression carefully, you're going to realize that this is indeed b plus ai quantity squared. I know some people don't like the word quantity, but that just means if I say b plus ai squared, it could be meant to use this, or it could be used to mean this, or it could even mean something like this. If I'm talking about this one, I kind of need to make sure that b plus ai stays together as a quantity. That's why we use the word quantity, okay? Now, so that is the answer. But wait a minute, we have the square and the square root. What is that supposed to mean? It means that we can basically just cancel them out, and this should equal b plus ai, right? But wait a minute. Depending on the values of a and b, depending on the branch you use, there are actually two possible answers, because this could be used to mean two different things. In other words, there are two numbers whose square equals this. In other words, if you square this, you get the same result. Make sense? So the answer could be b plus ai or minus b minus ai. Again, the values of a and b should be given, whether they're positive or negative, or which branch are you interested in, but these would be the possible answers. Now let's take a look at it from another perspective. For example, what is that supposed to mean? So if we take this one, it just switches the real and the imaginary parts. That's actually what I was trying to do. So if you have a number whose square root is 3 plus 4i, or 4 plus 3i is probably a better one, I think, then you can square both sides. You'll get 16 plus 24i minus 9, and that z would be 7 plus 24i. And what is the opposite of z bar? That would be -7 plus 24i. And when you take the square root, would it really be this? So in other words, if I square root this number, which is this number, is it true that this is equal to b plus ai, which means these two are going to switch, and that'll be 3 plus 4i? We can check our work. Let's square this and that. Of course, we're going to be squaring that one as well. Now let's see if this gives us 9 plus 24i minus 16. You know, I squared is -1. And that is -7 plus 24i. And that's indeed true. What happens if you take the answer to be -4 minus 3i? It is the same. It works because when you square this number, it is going to be the square of 4 plus 3i. They're going to have the same square. Okay? Let's move this a little bit to the left. So, oops. Let me see. Okay, here we go. I don't know, it's probably because of this. I'm at the edge, so gotta make sure. Okay, here we go. This is what I meant. So these two things are basically equal. Therefore, either one of them can be a solution. So what's the answer? The answer is, there are two answers, okay? If the square root of z is a plus bi, then the square root of the opposite of z bar is b plus ai or -b minus ai, depending on which branch you want to use. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cyber Math and A plus BI, and bye-bye.